So hello guys, welcome to the new video of GFG problem of the day. So today we have a easy level question, but according to me, we can't say it easy because it's a good question. And so let's go through the question. What is the question trying to say us? So the question says that we have been given. So the question says that we have been given a binary matrix of dimensions n into m. One can perform the given operation into the matrix. Okay, so we have been given a matrix. The size of the rows and column is not equal. Keep this in mind. It is a variable n and m. Okay, so if the value of matrix I comma j is 0, that is the value. Suppose we have a matrix 1 0 0 1. So suppose if the value is 0, then traverse in the same direction and check the next value. Okay, so traverse in the same direction means suppose if I am moving in this direction, so I have to continue in this direction only. Otherwise, if the value of matrix I comma j is 1, okay, then update the matrix I j to 0. Okay, so we have to update this to 0 and change the current direction from up, right, down, or left. Okay, up, down, right, left, to right. Okay, okay. For down we have to do left, and for left we have to do up. Okay, so these are the changes that we need to make. What is our aim is okay. Initially, you start with from cell 0 comma 0. So we initially start from the first element, moving the right direction. Okay, usual we do that. The task is to find the indices of the matrix which leads to outside the matrix from the traversal of the given matrix from the cell 0 comma 0 by performing the operations. Okay, so we need to tell that cell on which when I go it takes me out of the matrix. Suppose I have 1 0, suppose I have 0 0 1 1. I start with this cell, right? When it is 0, I don't have to do anything, I just have to traverse right. Again, if I get 0, again I have to do nothing, I have to traverse right. Here it leads to problem, and on this index I am coming out of the matrix. So we have to return here. We have to return here. This position is nothing but if I take 0 0 0 1 1 0 and 1 1, I have to return 0 comma 1. So this is my task. This is what the question is trying to say. Now let's move towards the example and let's try to understand the one example. Let's try to create a more clear image of the question. So suppose we have been given a matrix 0 1 1 0. Okay, so suppose I have been given this matrix which say which says okay, and okay, so 0 1 and 1 0. I would like to prefer for giving the index also 0 0 0 1 1 0 0, sorry, 1 0 and 1 1. Okay, so this is what is my indexing all the elements also. These are the rows, these are the columns, right? I'm starting from 0, that is this element. I check whether this 0 is what, like 0 or 1. This element is 0 or 1. If it is 0, then we don't have to do anything, right? And we have to move to the next direction. But suppose we have 1 now. Here we have got 1. And while it is 1, as it is 1, what do we need to do? What do we need to do? We need to change the direction to from right to down. We need to change this right to down. So now I will move down instead of going again on right. and I will change this 0 to 1, from 0 to 1 to 0. After this, again I will check this element whether it is 0 or 1. If it is 0, we don't have to do anything, we just have to traverse in the same direction, not in the right direction, same direction. Okay, yeah, this is 0 and we need to traverse in the same direction, that is down. Now if I go down from this element, obviously it will lead me out of the matrix. So because of this reason, we need to return 1 comma 1. You can clearly see that here it changed, the new matrix has been changed, this element has been changed from 1 to 0. Okay, this element has been changed from 1 to 0. My direction is also changed from right to down. In the next step, again from like as this is already 0, we just have to continue in the same direction, that is down. From here if I go down, cell coordinates out of the range, and because of this reason we have to return that index, and that index is nothing but 1 comma 1. So this is what is the question. I hope you all have understood the question. I will try to one last time explain the question by taking the last example. My last example, the matrix is 0 1 1 1 0 1 0 1 0 1 triple 1 double 0. This is my matrix. Let's give the positions: 0 1 0 2 0 3, sorry, sorry, 0 0 0 1 0 2 0 3 and 0 4, 1 0 1 1 1 2 1 3 1 4, 2 0 2 1 2 2 2 3 2 4. This is what is my matrix given. I start from the first index, that is 0. As it is 0, we don't have to do anything, we just have to move to the right direction. I find here that there is a 1. Right direction is going to change to down. So we go according to this algorithm, and I come change this 1 to 0, and I move down. I check that here I have 0, so I don't have to do anything, I just have to traverse next direction, next element, that is 1. Again I see that it is 1, so I change it to 0, and I change the direction from down to left. Let's move towards the left. This is my left. I move to left. I find again that there is 1, so I change it to 0, and my left direction is gonna change to up. I move up here. I find that here it is 1. Again I have to change the direction. The direction this will become 0, and the direction will change from up to right. I move to right. I checked. I see that there is only 0. There is a 0, so we don't need to do anything. We just need to traverse in the same direction, that is right. I move towards the right. I find that there is a 1. So my right direction again changes to down. I go down. I see that here there is again a 1. So as there is a 1, we have to change the direction from down to left again. So this becomes 0. I again move to left. Again I come to this 0. I see that there is no change. There is no change needed, as already it is 0. I come here. I see that again here there is no change needed. I have to traverse in the same direction, that is right, left, and here it gives me an error that it is going out of the matrix. So which position it is? 2 0. This returns me 2 0, because at this index it was going out of the loop, out of the matrix, right? So yeah, this is what is the question about. In this matrix, this example, it traversed a very good number of times. It has traversed this location also 2 comma 0 once, but coming the second time it has went out of the matrix, and because of that reason we need to return that index. So the question is quite clear. Now we need to go and think about some approach. The approach what is coming to my mind is that first we need to create something that can store the, or that can map the directions, like for all the directions, up, down, left and right. First I need to store whether it is what direction, what direction I have currently, and according to the condition whether it is 0 or 1, I need to change the directions. That's quite a good task that we need to do, and because of this I gave this question as medium. It is given easy, but I don't think so it is a easy question. So yeah, let's move towards the approach part now, the algorithm part. So for doing this thing out, saving the directions, or we can create a array, or we can create a pair, okay, which will be storing the directions, or which will be mapping the directions. So suppose if I take if suppose I have two fields in a array, okay, suppose I have two fields, I give this as the row and this as the column, okay. Let's consider a small straightforward matrix. uh, 1 1 1 1 0 0 0 1 1 0 1 1. Okay, when I need to move right side, okay, as you know that this is representing the number of rows and this is representing number of columns, okay. When I need to move this side, I need to increase this 0 with 1, right? So can I give my my right direction as 0 comma 1? Because when I need to move to my right side, I increment this 0 to 1. Again, if I need to move to the left side from here now again, okay, if I need to move from here to the left direction, what I need to do? What I need to do? Okay, that thing let's see after a bit of time. Suppose from this 0 0 I need to move down. What do I increase? This time I am increasing this 0 to 1, okay. So for going right, this is working, and for coming down, this is working. So the row column is changing to 1 and column is remaining 0. Now for going left side, let's check it out. For going left side, okay, if I want to go to left side, what I need to do is I need to decrement this column with 1. I need to decrement this by 1 now, right? So I can write 0 comma minus 1. I need to decrement, right? If I do here 1 minus 1, then only it will lead me to 0. That's why I write 0 comma minus 1. And if I need to go down, sorry, up, if I need to go up, so my this one has to change to 0, right? So for going up, I need to write minus 1 comma 0. Is this working? Is this working? Yeah, very well. It will work very well. If I need to go to right, I can increase plus 1. If I need to go to left, I can decrease minus 1. Okay. These both are handled by the column side. We have a pair of row comma column. Okay. My left and right direction will be handled by whom? Column side. Okay. And my row side will handle the up and down feature. Okay. Down feature is handled by giving increment of 1, and up feature is handled by decrementing 1. So these are the fundamentals of getting the directions. Okay. Still we haven't gone to the logic of saving the direction on which currently we are. We will do that. So we got one thing, that we need to create a pair, or we need to create a storage, temporary, this is our storage, okay, which will store the Directions for right, it was, I will write it now fastly. And so 0 comma 1, this will be storing the right direction. Left direction will be stored by this, okay fine. Down direction will be stored by 1 comma 0, okay. Left will be stored by 0 comma minus 1, and right will be stored by, sorry, and yeah, this is right, okay. 1 comma 0 is down, 0 comma minus 1 is left, and minus 1 comma 0 is up, okay. So this is my array, which will be storage for my directions, okay fine. Very well understood. So now, as we got familiar with the logic of storing the directions, we can move forward with storing the direction on which currently we are. For storing the direction, let's create a variable which will be traversing this array itself, because this is storing the directions, right? See, directions can be from left, right, down, or up. Only four. We have four choices, right? That is, we have options from only this array. So what we can do is, we can declare a array. Suppose it is direction array. Okay, sorry, we can declare a variable. In this variable, what I can store is 0. Why? Which direction are we currently from the starting? Right direction, right? Which is the first element of this array. So 0. Okay, fine. Now, as we know, suppose we have this vector, this matrix. How do we give the indexing? Like this, right? What I will do is, I will divide this also, 0 0 0 1 1 0, this 1 1, and I will declare them as a variable, okay. I will declare this as x, this is my x, this is my y. What we can do is, we can just increment 1 in y. Okay, if I increment 1 in y, that means I want to move in the right direction, right? If I decrement 1 from this, from okay, if I decrement 1 from y, it becomes 0 0. That means it goes to the left direction. Decrement means this. Now, if I increment 1 in x, it moves to down, right? See, and if I decrement 1 in the same x, it will lead me to up direction. So that's why I need to have a hold over this 0 0, this indexing also. That's what I'm doing. So now we are familiar with all these things, okay. Now we have got everything what all we need. Basically, we have our directions also, we have our current direction stored also, okay. I have my indexing stored in my x and y also, so that I can manipulate my directions. I increment y in 1 in y, it moves, takes me to the right direction. So now everything is in my hand, okay. Now what we can do is come to the logic part, and we can implement those two, whatever that conditions were given, that if it is one, that what we have to do, right? For 0 we don't have to do anything, just don't worry. Just for 1 we have to do, so that we will see what we can do. So now let's think on that thing. And after this, when we have all our variables set, when we are currently on the right direction, also right direction, okay. Now we need to do is that, suppose if I find 1, I need to perform the for that conditions. So for that, now let's see what can we do. First of all, this is clear that we need a loop, right? We can't use a for loop. We need to use a while loop, because we need to check some certain conditions. Our conditions can be that if my x, okay, if my x, that is this 0 0 and 1 1, The size of this matrix is 2 cross 2. So what can be the maximum value and minimum value of x? It can be either 0 or 1. Value of x belongs to this. Value of y also, if you see, belongs to 0 and 1 only. That means x and y needs to be in the range of less than 2. Okay, and greater than 0 obviously. So if my x is greater than 0 and x is less than 2, along with this, what we need is the y should also be greater than 0 and y should be less than 2. But as we need to check all of these x, y, both, we should use here and condition instead of or. So yeah, while my this condition, unless this condition is getting true, my this loop will get executed. What do I have to execute? I have to check whether my what is one, my matrix of x and y is 1. If this is 1, then I need to perform some certain conditions, right? I will check those conditions now. First of all, what we need to do is very clear. I need to change that element to 0. So this is sure. Other than this, what we need to do, let's see. What we need to do is, if my direction is currently right, okay, I will copy this array and yeah. So what I do is, suppose my direction currently is right. Okay, for right direction I need to change it to, for right direction I need to change it to down. That means I need to increment my x by 1. Okay, now I need to increment by x by 1, but as my x is not storing the these variables, okay, these variables are totally gonna accessed by whom? Dir variable, because dir is the one who is getting iterated in this array, choosing the directions, right? So what I can do here is I can write dir equals to dir plus 1. Okay, so suppose my dir was this, currently 0. Okay, I need to go to a down direction. Okay, I need to go to direction, which direction? Down. I need to add 1 in it. Do you accept? Yeah, I need to add 1 so that my dir comes from here to here. It comes on this index now, so that means I am on down index now. That's why I wrote here 1. Again it adds 1, again it adds 1. There will be a time it will cross this index 0, 1, 2, 3. It will become 4, right? And at this time it will start failing. So to stop this thing, we can use a logic and we can make a mod of 4 here. As we have 4 directions, I need to keep the remainder between 0, 1, 2 and 3. So for this I am modding it by 4. Okay, that's a small logic which I have used here. Now this is doing what? This is telling me which direction I have to be. Okay, but still, but still, it moves in that direction, but it can't access the elements, right? For accessing the elements, particularly, we need to access our x and y. Got it? We need to access our x and y. These two are only gonna check whether the element or the index has crossed the matrix or not, whether it is going out of the matrix or not. If it is going out of the matrix, then we have to stop and we have to return that index, right? So for that I need to do something on x and y. I need to perform some operations on x and y. Let's check whether what can we do so that we have the access to x and y also by the use of this dir. So one thing which is coming in my mind is we can do is, for accessing our x and y, which are going to tell whether the index has gone out of the element or not, out of the matrix or not, what we need to do is we need to check out whether we need to increment our x and y with these 0 1 and 1 0 or 0 minus 1, all these things, right? Because I told you there itself that if suppose this is the matrix, okay, if suppose this is the matrix, need to move to right direction, I need to add 1 to y. Got it? That means I need to add something to y, that is 1. Okay, for right direction. So what I will do is I will add it. I will instead of adding 1, what I can do is, see, for right direction if I add 1, I need to add for left direction also. So instead of doing all these things, we have made an array. Let's make use of this. Okay, what we can do is we can access this, because we have got the direction in which direction we have to go in this variable dir already. So what I will do is I will go to that element of dir. Suppose we have to move here on right direction. So dir is 0. So y plus dirs of this, I have to add 1, right, to y, right? I have to add 1. Not for first dot second. If I do dot second here, if I do dot second here, it will add 1 here, y plus 1, right? Now if I want to move to left direction, suppose I am on 1 1, I want to move to right direction, left direction. What I can do is, what I can do is I will just go to I am on currently, I want to go to left, right? So I will come here. Okay, and now suppose if my dir is 0 1 2, so dirs of 2 it will take, and dot second, that is it will decrement by 1, automatically it will move in the y direction. So I need to do this play out, and suppose if it comes out of the matrix, just I have to return that. So after doing this thing out in my if condition, what I can do is I can declare a variable. I need to declare a variable. I will tell you why I need to declare these two variables. I need two variables, and I need to add the same thing here. For y, I need to add y plus that direction. Okay, dot second, and here I need to add x plus that direction, and dot first. So yeah, this will keep the next index where I need to go. Now what we will do is I will check whether this dx is going out of the range or not. Okay, so now I will tell you why I have declared this dx and dy. It is very necessary to do this, because if I don't declare these two variables and I directly increment my x equal to x plus, y equal to y plus, now my x and y have incremented, right? And if I check this condition now, if I check this condition now, this will not work. I have to check for the x which is coming from up, the y which is coming from up, right? So that's why I need to check this x and y. Okay, I will check whether my now dx is greater than what is the size of matrix, the row dx, so is greater than row. Okay, or my dx is less than the row, or my dy is greater than the column, or it is less than the column. If any of these conditions gets true, if any of these conditions gets true, we need to just return the old x and y. Okay, I need to return that old, where it is going out I have to return, right? I have to return that old index. Suppose this is the suppose this is that, okay, matrix. On 0 it was going out. Suppose on 0 it is going out. Okay. Now my dx and dy will be storing the next. This dx and dy will be storing the next. Suppose this is 0 0 0 1 0 2, but I don't have any 0 2. But still, my x is storing 0 and dy is storing 2. Now it will check whether dx is greater than row. Yeah. So it will return this thing. It doesn't has to return 0 2, right? It doesn't has to return 0 2. It has to return 0 1. This is the reason we need to declare this dx and dy. Dx and dy, I will repeat, dx and dy are checking whether this next position is getting out of the matrix. If yes, then we don't need to return dx and dy. We need to return this. And if it is not making a problem, if it is not making a problem, Simply I will make x as my dx and y as my dy, because they are not making any problem. Simple. And again it will go on, this loop will go on, while loop. Wherever it will find that this is going out of the row, or less the row, greater than column, less than column, there itself it will return x and y. Simple. And if suppose there is no such x and y, it can't find, at last we will return my x and y. Simple. So I hope you understood the reason why I have to declare this x and y, or dx and dy, these two variables. Okay. I hope you understood what is this dir variable doing. I hope you understood what is this dir's, the storage doing, storing the directions, right, down, left, up, like a dictionary. It's like a dictionary, okay, of directions. Okay. And dir is a iterator which is iterating this dictionary. And x and y are particular elements, or the indexes which are getting affected. And dx and dy are what, the future index of the like the future index, the next index. And this next index is going to check whether this next index is going out of the matrix or not. If it is going out, then I have to return the previous index, not dx dy. I have to return the previous index. This was the reason I have to declare dx and dy, right? I hope you are clear with this. Now what we are going to do is we are going to check out the code, how this can all be like messed up in a code. So yeah, let's go to that part. So the code that I needed to write was, we can go according to the following algorithm whatever we have seen. The first thing what we needed to do was, we needed to create a dictionary, or we need to create a, storage that will be storing my directions, right? Before that we need two variables that will be storing the size of the matrix, right, the rows and the column. So that will be quite easy. I can store the row by giving matrix dot size, right? This will give me easily the rows. And for number of columns we need to check whether the particular index, so matrix of 0 dot size, or any element 1 2 3, because columns are going to get same. Okay, now I need that storage which will be keeping the size, sorry, the directions, right? So let's name it as dirs. And let's this will be a pair, right? This will be a pair, like vector of pairs, which will be storing int comma int. Okay. And yeah, so the first element I need to give is for right direction. For right direction what we had was for right direction, say 0 comma 1, right? Okay. Then for left direction I had, for down direction I had 1 comma 0. Okay. Then for left direction I had 0 comma minus 1. Okay. And for up direction we had minus 1 comma 0. So here we are done with the making the storage for the directions. After this, what we needed was the iterator, which will be iterating the dir's vector. Okay, we need to initiate it to right direction, that is 0. Then I need one x which will be 0 initially, and I need a y which will be 0 initially. X and y, you know very well what are they. Now we go to the while loop, which will be checking whether my x and y are in the matrix or not. So what conditions do we need here? Say, if my x is greater than 0, x should be greater than 0, and x is what, the yeah, x is the row, sorry, x is the row. So whether x is less than n, then my x is y is greater than 0, and y is less than m. Okay, these conditions will now check whether my x and y or whatever the elements the index is inside the matrix or not. Then we needed to check whether my matrix of x and z, sorry, x and y, is it one? Is it one or not? If it is one, I need to change my dir to dir plus one mod 4. We were doing mod 4 because it needs to be in the range of 0, 1, 2, 3, right? Okay. And finally, matrix of x and y will be 0. Okay. I need to change that element to 0, obviously. Okay. After this, what do we need to do was say I needed to declare that I needed to declare that variable which will be storing the future x, right? So it will be storing the future x like this x plus dirs of dir, okay, okay, right? Dot first. So all the first elements are my x 0, 1, 0, minus 1. Okay. Similarly, all the second elements are my y, right? So yeah, y. Now, if I find if I find that the future element, a future index that is dx and dy are going out of the matrix, okay, that is if it is less than 0 or my dx is getting greater than n, or my dy is getting less than 0, or my dy is getting greater than m. In all these conditions, I need to return not the future. I need to return that x and y on which after which they are going out. So I need to return. This will be in a form of pair, right? Because we are returning a pair. It is given that we have to return a pair. So yeah, I will be returning this pair. And if all these conditions are true, then at last simply we have to return x and y, right? If suppose it doesn't goes into the while loop, then simply we need to return that index, and this will be the code for it. Whatever I did in the logic part, I have simply done that. Yeah. So there is an declaration error, and we are getting 0 comma 0, and we need 1 comma 1. So we need to check whether it is equal also, right? Because we have to keep it, because x and y are starting from 0, right? Similarly here, whether it is less than 0 or greater than equal to n, because it can't become anytime. See, when the size is 2 comma 2, right, x and y stop at 0, 1, 0, 1. So we don't have to check, we have to check for that also. And finally, if I give a run now, so I we have forgot to write this, right? We have to make this equal to, if this condition is becoming false, if this condition becomes true, then we have to come out. Otherwise we have to give our new x as the dx and dy, right? The next position. I forgot to write this, sorry. And now I get my final output. Let's try to submit this solution, and let's try to check whether this is a valid solution or not. Okay, it is going. Let's see. Okay, so it has passed and it has taken 3.75 ms. Okay, fine. So this was our solution for today. Hope you like the video. If you have understood, then please like, share, and subscribe. And if you have any doubts, just ask it. Feel free to ask it out in the comment section. If you want to get any type of guidance or any type of, you want to talk with me, you can come on LinkedIn. I have kept my LinkedIn ID on the description. So that's all for today's video. Let's meet in some other question. Till then, keep coding. Bye bye. Jai Hind.